Alright, another kind of method for solution for systems is called elimination. Elimination is where you add the two together and you get a variable to cancel out. Example, if I have 2x plus y is equal to 5 and x minus y is equal to 1, I can solve this equation using elimination. Now this one's very basic because we don't have to change anything to solve it. I've got two variables, my y, that have the same coefficient. It's 1y and 1y. One's positive, one's negative. I'm going to add these two equations together. The reason I can do this is because if I add x minus y to this side and 1 to the other, I haven't changed the value of my equation because x plus y and 1 are equal. They're equivalent. So 2x plus x is 3x. Y minus y eliminates, cancels out. And then 5 plus 1 is 6. And that's really about it. You pull the 3 off the x is equal to 2. Once I know x is equal to 2, I can take and substitute it into any equation. I'm going to use this equation right here because it's nice and easy. X minus 2, or x is 2 rather, 2 minus y is equal to 1. So I've got my new equation. Pull that 2 off both sides. Negative y is equal to negative 1. Divide by negative 1, and y is equal to positive 1. And so my solution I can list as a point, 2, 1. Now this one I said was easy. Everything's all lined up, and it's good. Let's look at one that's maybe not so straightforward for elimination. Let's say we have 3x plus y is equal to 6, and 2x is equal to, y plus 4. All right? Now let's change this. Let's make it 7y plus 4. All right. So we're looking at these two, and you'll notice not only are they not lined, they don't have the same coefficient, but our variables aren't lined up the way they should be. So let's change that. I'm going to pull this 7y over to the other side. And the reason I'm going to do that is so when I rewrite it, so I've got 3x plus y equals 6, and then 2x minus 7y is equal to 4. The reason I have pulled that y to the other side is so that my y's and my x's line up. Alright, that way visually I can subtract or add rather straight down. But now, if I add them the way they are, nothing will cancel out. 3 plus 2 is 5. 1 plus negative 7 is negative 6. Nothing cancels out. My variables are all still there. So I'm going to adjust this equation by multiplying it by 7. Why would I want to do that? Why would I want to multiply by 7? The reason is because if I multiply by 7, everything is multiplied by 7. My y's now cancel out. This is what I want. I want, when I add these two equations together, for one of the two variables to go away. In this case, my y's will go away. So I'm going to take these two equations right here. 21x plus 2x is 23x. My y's cancel. 42 plus 4 is 46. I pull that 23 off my x, and x is equal to 2. Done with my x's. I'm going to go back and substitute in for my y. Or substitute in and find my y. So 3x plus y is equal to 6. I found x to be 2. So 3 times 2 plus y is equal to 6. That's 6 plus y is equal to 6. Pull the 6 from both sides. And I'm going to get y is equal to 0. Don't be afraid if you get something equal to 0, like a y or something. If you've done all your math correct, it's in fact the answer. Alright? If you have y equal to 0, that's fine. This is my point. Now, let's say you did get a 0 and you were a little shifty on, is that the right answer? It's very easy to check system problems. 3 times 2 plus 0 has to equal 6. That's just this equation with my two values substituted. And my second equation has to work. 2 times 2 equals 7 times 0 plus 4. If you carry the math out, both of those equations work. All you have to do is substitute your variables, substitute those values in for your variables, and if it works out, you have successfully completed the problem.